Hello students and welcome back. We'll be looking at percent composition in this video. Compounds have a specific molar mass. That's because the atoms that make that compound or the elements that make that compound also have a particular mass to them. So the percent composition is going to be the mass percentage of those elements in that particular compound. Now to solve for it is very easy and we can use a basic formula to do so. So that formula is going to be the mass percentage or the percent composition is equal to the element mass total divided by the compound mass total, and then we multiply it by 100 to change it to a percentage. Or to put it in step form, first thing you need to do is add the compound molar mass. So all you got to do is look at your periodic table, find the atomic mass numbers for each of your elements, and add them up. Your second step is add the mass of all atoms for a specific element. So for instance, if you had 3 nitrogens, you would add 14 plus 14 plus 14, or you could do 14 times 3 to get that total mass for nitrogen, and you'd move on and calculate the masses of the next element that is unique or different from nitrogen in this case. Third step is you divide the specific element mass by the molar mass. Again, if I was using that nitrogen, I would divide the total mass of those 3 nitrogens by the total mass of the compound, the total molar mass of the compound. And then the last step would be to simply multiply my answer by 100 to change it to a percentage. It's all fairly simple, but we'll do a couple example problems just to give you an idea of what we're doing. Now sometimes these questions may be worded differently. In this case, I'm asking for each element. Sometimes the question may ask for a specific element or elements. In this case, we're looking for all of them. And we're going to be looking for the percent composition of each element in H2O. So the first thing I need to do, that first step, I need to add the compound molar mass. So I need to add up all my elements. Alright, so I got a hydrogen and I got an oxygen. From my periodic table, I will be using the atomic mass number for each element, and I am going to round to the nearest whole number for each atom or each element. So hydrogen is 1 gram and there's 2 of them, so that gives me 2 total grams of hydrogen. Oxygen is 16 grams, there's 1 of them, so that gives me 16 total grams of oxygen. Altogether I have 18 grams in H2O. Now we can do our percent composition. We did the first step, which was add the compound molar mass. The second step is add the mass of all atoms for specific elements. Well, we kind of already did that. Our work shows that hydrogen represents 2 grams, oxygen represents 16 grams. So our next step is divide specific element masses by the molar mass. And then we're going to multiply that by 100. Or if you like to see formulas, mass percent is equal to element mass total divided by the molar mass total times 100. There's our formula. So we'll do hydrogen first. So our formula for hydrogen is hydrogen mass percent is equal to the element mass, which is 2 grams, divided by the molar mass of the compound, which is 18 grams, and I get 0.11. Now on my calculator it did say 0.1 continuous, but I'm just going to stop at 0.11, 2 numbers past the decimal. So 0.11 times 100 is 11% hydrogen. Now we can do oxygen. Oxygen mass percent is going to be 16 grams for oxygen divided by the 18 grams total. And I'm going to get on my calculator 0.888. Now I'm going to round this to 0.89. I multiply that by 100 and I get 89% oxygen. With percent composition, you can check your work to make sure you're doing somewhat accurate. 11 plus 89 gives me 100%, so I should be okay with this one. If you ever get, say, between 99 or 101%, you should be okay. That might be due to just rounding errors or just rounding differently. But if you ever get something like 75%, you probably messed up somewhere. All right, let's do the next one. What is the percent composition for each element in CO2? So we're dealing with CO2, so let's find the molar mass of CO2. So CO2 has a carbon and an oxygen. Carbon is 12. We multiply that by 1 to get 12 grams total. Oxygen is 16. There's 2 of them because we got a subscript of 2. That gives me 32 grams. We add those together and we get 44 grams total for carbon dioxide. Now we can just follow our formula or follow our steps. So our formula again was the mass percentage is equal to the element mass total divided by the molar mass total. And then we multiply that by 100 in the end. So the carbon mass percentage is equal to the element mass. We said our element mass was 12 grams divided by the total molar mass, which is 32. The total molar mass, which is 44 grams. Do that math real quick. 12 divided by 44. We get 0.273 times 100. We get 27.3% for carbon. Next up, we do oxygen mass percent. That's going to be 32 grams for the individual oxygen over 44 grams for the total carbon dioxide. Do that math. 32 divided by 44. I get 0.7272. So I'm not going to round it. I'm going to leave it though. That's 0.727. Now multiply that by 100 and I get 72.7% for oxygen. Now we can add those together to just check our work. 72.7 plus that 0.3 makes it 73. Then 73 plus 27 gives us 100%. So it looks like we are good. Alright, and our last example, make it a little bit more challenging. We got ammonium carbonate, NH4 CO2. So there's a whole lot of elements in this one, but we can handle it, we can figure it out. Let's break down this compound and figure out its individual atomic masses. Alright, so I got N, I got H, C, and O. So N, H, C, and O. Okay, all of them represented. So nitrogen is 14 grams. Now there are 2 nitrogens. Since there's a 2 on the outside of this parentheses, it multiplies my nitrogen by 2. So 14 times 2 is 28 grams. My hydrogen is 1. Now 4 times 2 is 8. So there's 8 of those hydrogens. So hydrogen is 8 grams total. Carbon is 12, and there's just that 1. Oxygen is 16, and there are 2 of them. So that's 32 grams total. Now to get the total molar mass, we add everything up. We got 28 plus 8 plus 12 plus 32. And that is a total of 80 grams. Good clean number. Alright, now we take our individual masses and divide it by 80. Now, had the question said maybe what is the percent composition of nitrogen in this compound, all I would have to do is just nitrogen. I would do 28 divided by 80 times 100, get that answer, and I would be done. But for this example, I'm just going to do all of them just for good practice. So let's do the first one. So we know our formula now is mass percentage equals the element mass divided by the molar mass times 100. So I'm not going to write it out this time, but just be aware of it. So the nitrogen mass percent is the element mass, which is 28 grams, divided by the molar mass, which is 80 grams. So 28 divided by that 80 gives me 0.35 even. I multiply that by 100 and I get 35% nitrogen. Now we can do the next one. Hydrogen mass percent is the individual mass of 8 over the total mass of 80. 8 divided by 80 gives me 0.1 times 100 is 10% hydrogen. Next one, got carbon. Carbon mass percent. Individual mass of 12 over the total mass of 80. 12 divided by 80 is 0.15 times 100 is 15% carbon. Now, if you're feeling real confident in your work, you can take 100 minus 15, minus 10, minus 35, and that would tell you the remaining percent is oxygen. But I like to be thorough. I like to go ahead and do the work. So if we do oxygen, we got oxygen mass percent is equal to its individual mass of 32 grams divided by the total mass of 80. 32 divided by that 80 is 0.4. 0.4 even times 100 is 40% for oxygen. Now the last thing we're going to do is double check our work. 40 plus 15 plus 10 plus 35. I get 100, so it looks like we're good. So that is percent composition. All you got to remember is your formula, or you can remember your steps. Hope this video helps, and as always, good luck on your tests.